Hello, welcome back. So in this video, I am going to describe the type of transformation that has been applied to the rational parent functions. And as you may know, the rational parent function is f of x equal 1 over x. So in order to go from the parent function to a more I would say advanced rational functions, okay, different kind of transformation has occurred from the parent function to the function g of x, and you're going to describe each one of them. So I am going to start with the k, okay, so right here. So when do you have the k? So what does the k describe? Whenever you see a number being added to the fraction, to the rational term, you refer to the k as the vertical translation. Okay, and because here the number for the vertical translation is positive, so I know the direction is going to be up and up k units. So the parent function has been shifted upward k units. Okay. Now, so and also this number also refer to the horizontal asymptote. And usually the horizontal asymptote is written as y equal k. Okay, and there's always something I would like you to know is that if you have multiple transformation, the order matter. The order of the transformations that you describe does matter. So the vertical translation we always come last. Okay, it's always last. So I would like you to write the vertical translation always last. Okay, so now next move on to the next transformation. Again, if you see a number being added to the rational term, the fraction, that number is the vertical translation, the number for the vertical translation, and the parent function has been shifted up k units, and it's also referred to, k also referred to the horizontal asymptote, which is going to be the line y equal k. Remember, vertical translation always come last. Now, the next one comes is this expression here. So we have x minus h. Okay, so what kind of transformation do you have here? So any number you see being added or subtracted from the s always refer to the horizontal translation. Okay, now because, and the horizontal translation is always going to be the opposite. You're going to do the opposite of whatever you see. So if you see here negative number, negative h, don't think of it, okay. So basically horizontal translation, you need to figure out if the parent function will be shifted to the right or to the left. Now, because you have a negative here, you may think, okay, the parent function has been shifted to the left, but it's not correct. It's always going to be the opposite of whatever you are thinking. So if it's negative h, so the parent function has been shifted to the right h unit. So right, you're going to say right. So the direction is right. It's always the opposite of what you think. It's right h unit. Okay. And also the number for, so if you have a rational function that follow these templates, okay, so this expression here allows us to find the vertical asymptote. This expression here allows to find the vertical asymptote. And how do we find the vertical asymptote? So the vertical asymptote is going to be x minus h, and you set it equal to 0, and you solve for x. Okay, and x here, the vertical asymptote will be x equal h. Okay, so how do we find the vertical asymptote? You take the denominator, and you set it equal to 0, and you solve for h. So for h to be your lone, you have to add h on both sides. So that's why x equal h. So the horizontal asymptote and the vertical asymptote is a vertical line that cut the x-axis at a given value, which is here h. Okay. So now the next transformation I'm going to show you is this one right here. Okay, so what do you have here? So what kind of transformation do we have here? So you see, so we have a negative right here, so we know that it's a reflection. So remember, this represents the y, the output, the y value. Now the y value are becoming negative. So the only time you can, the only transformation that will allow us to go from positive y value to negative y value is a reflection across the x-axis. Okay. And the last one I'm going to describe here is A. A, the number multiply, the number on the numerator. So now if A, so if A, so when you have A is greater than 1. So for this example, I'm only going to show you an example where A is going to be greater than 1. So if A is greater than 1, what kind of transformation do we have? So that's when you have a vertical stretch by a factor of A. So basically, you need to multiply the y value by the factor A. Okay, so let me give you some example then. So let me find an example first to do here. Oh, and I also forgot to include the horizontal translation. Always, okay, you always want to write the horizontal translation always first. Okay, so now remember the vertical translation is always last. You always want to describe it last, and the horizontal translation always come first. Okay, so I am going to find an example so we can practice together. Okay, so let me start with the easiest example, and then you're going to do more advanced. So you're going to describe the transformation here. So I give you the template. Okay. So the transformation, the rational function I have for number 1, I have g of x equal 4 over x minus 5. Okay. So look at the example from above. Okay. And describe the transformation. Please pause the video and describe the transformation. Okay. So here you only have 2 transformations. So if you want to start with the, I said earlier that always, the horizontal translation always start first. You only want to write it first. We don't have any number being added or subtracted to the x. So there's no horizontal translation. The parent function has not been shifted to the left, neither to the right, neither to the left. Okay, there's no horizontal translation. So the only transformation you have here is, because you see the number on top is here is not 1 anymore. So if A is greater than 1, not including 1, there's no line under the inequality, so A cannot be equal to 1. So if A is equal to 1, if you have a 1 here, you don't have a vertical stretch. We only have a vertical stretch if we have a 4 here, a number greater than 1. And 4 is greater than 1, so that's why I said, okay, vertical stretch by a factor of 4. Right. So now, the last transformation is the vertical translation. So you see there's a number being subtracted to the rational term. Okay, so that's why I say the vertical translation down 5 units. Okay, so let me give you another example for you to practice. Okay. Okay, number 2, again, g of x is equal to -2 over x plus 3 minus 1. Again, so you want to use the transformation from above. Look at each one, okay, and describe the transformation, okay? Pause the video and describe the transformation by yourself. Okay, so here we can see that you have now 4 transformation and the other matters. So that's why I started with the horizontal translation. I see a number being added to the x, so it's going to be horizontal translation. So it's horizontal translation, so it's going to be the opposite of whatever you see, the sign that you see. So if you see plus, don't assume that you're moving to the right, but it's going to be the opposite, it's left, and it's 3 units. Now, the next transformation can either be, if you wanted to put next the second order, the second place, the second transformation to be a vertical stretch by a factor of 2, because you have a number on the numerator that is greater than 1. Okay, so that's why I say vertical stretch by a factor of 2. So if you wanted, you could have put the vertical stretch by factor 2, number 2, as a transformation number 2. Okay, but yeah, you could have switched those 2 places with the reflection across the x-axis. Okay, together. So again, negative means reflection across the x-axis. The 2 means vertical stretch by a factor of 2. And again, the last transformation is a vertical translation down 1 unit. And just a reminder, like a vertical stretch by a factor of 2 means we want to multiply the y value by 2. Okay, so this tells you to multiply. So this is telling you to multiply. If you're going to graph, so you start by graphing the parent function and you follow the transformation 1 step at a time. And when you come to the third transformation here, you want to multiply the y values by 2. So you don't want to add 2 to it, you want to multiply the y values or the y coordinate of the other pair from the parent function by 2. Okay, so that's the example I have. Let me give you one more. So the last one, so number 3. So I have g of x equal to, okay, 1 over x minus 1 plus 2. Okay, so please pause the video and use your note from above, from here, to describe the transformation for number 3. Okay. Okay, so here for number 3, you only have 2 transformations. And again, when you have multiple transformation, the order does matter. And there's no negative, so yeah, there's no reflection across the x-axis. Now the number on the numerator is 1, and 1 is not greater than 1 than itself. So there's no vertical stretch here, neither. Okay, so but what I notice here, I see a number being subtracted from the x. So the first transformation always is the horizontal translation. So you're going to go to the right 1 unit. So it's always going to be the opposite you think, what you are thinking. So if you see -1, you think, oh, the parent function is moving to the left, but it's the opposite, right? Okay. So now the vertical translation is what you see is what you get. So a number is being added. So it's a vertical translation. And because the number being added to the rational term is 2, so that's why I wrote up 2 units. Okay, so I think I'm going to stop here for the video on describing the transformations. Okay, so I hope this video was beneficial to you. Okay, so thank you for watching my video and have a wonderful day and see you into the next one. Bye bye.